This is what people think they'll see through a telescope. And this is what they actually see. Everything here is a live, real-time simulation of an 8-inch telescope. No long exposures, no stacking, just what hits your eye. 15 objects, a few will genuinely impress you. And one of them, the one you're all going to ask about, you won't see at all. Not a faint version, nothing. Let's start with the one that never disappoints, except you're catching it at the strangest possible moment. Through the eyepiece, Saturn is tiny, about a grain of rice held at arm's length. And the rings aren't a ring, they're a line. A thin, bright blade running straight through the planet. That's not your telescope failing. In March 2025, the rings turned edge on and vanished completely. Something that happens once every 15 years. They're reopening now, about 7 degrees and climbing. You're looking at the rarest version of Saturn there is, and that pale dot beside it is Titan, the Orion Nebula. In photos, pink and violet. In the eyepiece, gray. And here's why, and this explains almost everything else in this video. Your eye has two kinds of light sensors. Cones see color, but they need bright light. Rods work in the dark, and rods are colorblind. Every faint object in the sky is being seen by your rods. So it isn't that the color is missing, it's that you're not equipped to see it. What you do see is a curl of gray smoke and 4 sharp stars burning at its core. Venus, the brightest thing in the sky after the sun and the moon, bright enough to cast a shadow on a genuinely dark night. Point a telescope at it and you get a real surprise. Venus has phases, a perfect crescent, exactly like the moon. And that is all you get. No continents, no storms, no surface at all. Venus is wrapped in clouds of sulfuric acid so completely opaque that no telescope on Earth has ever seen its ground. The only photographs of that surface came from probes that landed on it and died within 2 hours. Mars is where it hurts. Even at its closest approach, Mars is a dot. An orange bead boiling in the atmosphere, refusing to hold still. On a good night, you'll catch a white speck at the top, that's the polar ice cap, and a dark smudge across the middle, which is a volcanic plain the size of Europe. That's it. That's the whole show. Every crater, every canyon you've ever seen in a Mars photo was taken by a machine that flew there. Now the opposite. Remember the cones, the color sensors that need bright light? Jupiter is bright enough to wake them up, so Jupiter keeps its color. Softer than the photos, but real, 2 dark cloud belts running across a cream-colored disk. On a calm night, the great red spot shows up, smaller and paler than you expect, more salmon than red. And strung out beside the planet, 4 tiny diamonds in a straight line. Those are the Galilean moons. Galileo saw exactly this in 1610, and it ended the idea that everything orbits Earth. The Pleiades. Those blue clouds wrapped around the stars are real. It's dust. The cluster is drifting through, scattering starlight, but it's brutally faint. Under a dark sky, with the telescope, you might catch the faintest gray haze around the brightest star. Might. And there's a second problem nobody warned you about. The Pleiades are too big. The cluster is 6 times wider than the full moon. Point an 8-inch at it and you don't see a cluster. You see 4 stars and a wall of black. 4 million suns collapsed into a single point, 26,000 light years away at the center of our galaxy. Here's the reality. You see nothing. And not for the reason you think. Between you and it sits the galactic plane, gas and dust, so thick it dims visible light by a factor of roughly 1 trillion. Nothing gets through. Now, you've seen the famous image. The orange ring. That one's real, but it isn't visible light. It's radio, captured by telescopes on 4 continents wired together into one Earth-sized instrument. And even that isn't the black hole. It's the glowing gas circling the drain. The black hole itself has never been seen. Good news. The Ring Nebula is a star that died and blew its outer layers off into space, and it looks exactly like what it is. Gray, yes. Small, you'll hunt for it between 2 stars in Lyra, but the shape survives. A perfect smoke ring floating in the dark, with a hole in the middle you can actually see. This is the object that converts beginners. Not because it's spectacular, because it's unmistakable. You know instantly you're not looking at a star. Now, something the eyepiece actually wins at. Albireo, in the constellation Cygnus, looks like one ordinary star to the naked eye. Through the telescope, it splits into 2, and they are different colors. One deep gold, one sharp blue, sitting right beside each other. Remember the cones, the color sensors that need bright light? These 2 are bright enough, so the color is real, and it's obvious, and it needs no photograph, no processing, and no long exposure. It is simply there, waiting. Neptune, 2.5 billion miles out. In the Voyager photo, it's a deep blue world with weather. In the eyepiece, it's a blue-gray pinhead you'd walk right past. There's exactly one way to know you found it. Stars twinkle, Neptune doesn't. It's a disk, not a point, so the atmosphere can't make it flicker. Sit on it long enough and it just sits there, steady, refusing to blink. And if your sky is dark, a faint speck sits beside it. Triton, orbiting backwards. Hundreds of thousands of stars, packed into a ball 22,000 light years away, most of them older than the galaxy's spiral arms. You'd expect a swarm. What you get is a ball of cotton. Featureless white in the middle, because the stars are too crowded to separate. But look at the edges. The rim breaks into grain, individual points, flickering in and out as your eye adjusts. That's the moment it stops being a smudge. You're resolving individual suns. Pluto. 3.5 billion miles away, and this is the hardest thing in this entire video to see at all. Under a genuinely dark sky, an 8-inch telescope will show it as a dot. Not a small planet, not a disk. A dot, identical to every other dot around it. There is exactly one way to prove you found Pluto. Come back the next night and see which dot moved. That is precisely how it was discovered in 1930. Clyde Tombaugh found it by comparing photographs, hunting for the single point that had shifted. The closest star to the sun, 4 light years away, our next-door neighbor. And you cannot see it with your naked eye, not from a dark sky, not from a mountaintop, not ever. Proxima is a red dwarf, small, cool, and roughly 600 times fainter than the sun. Through the telescope, it finally shows up, a dim red pinprick, easy to lose among brighter stars behind it. And it has a planet, roughly Earth-sized, in the temperate zone, around that unremarkable red dot. The whirlpool, the textbook spiral galaxy, and the first one ever recognized as a spiral. 2 objects here, the big one, and a smaller galaxy caught on the end of one arm, being torn apart in slow motion. Both are visible. Both are gray. Under a genuinely dark sky, if you look slightly to the side instead of straight at it, the spiral arms come out, faint, curved, barely there. Look directly at them, and they vanish. Your eye is more sensitive at the edges. And last, Andromeda. 2.5 million light years away, and the reality is a gray oval with a bright core. No arms, no color. But the reason isn't what you guess. Andromeda isn't too small to see. It's too big. It spans 6 times the width of the full moon. Your telescope is looking at a fraction of it. You are standing too close to a galaxy, and that gray light, the light landing in your eye at this exact second, left there before anything we call human existed. It crossed the entire gap between 2 galaxies to end its journey in your retina. So when you finally look through a telescope and the view seems like a letdown, remember what you're actually looking at. Not a photo somebody processed for a month. Real light, arriving live, that has been traveling since before you were born, sometimes since before your species was. Which one should I simulate next? The Crab Nebula, Uranus, or Mercury? Pick one in the comments and it's the next video.